All right. You guys ready? So, yesterday we went over place values and rounding. Today, if you look at the calendar, we're going over what? Somebody tell me. Decimal, whole number and decimal operations. So it's going to be a long one today in terms of lecture because we're going to go over how to add and subtract, multiply and divide. Yes, whole numbers, yeah, but we're going to focus more on the decimal side. How to add, subtract, multiply, and divide decimals by hand. Yeah, because we all are used to doing it on the calculator, right? But you guys got to learn how to do these things by hand. So, let's start, why don't we? You guys ready? You guys ready? You guys ready? All right. Let's start with the one that everyone likes, adding by hand. If we're given something along the lines of this, pretty cool how it's all digital, right? Thanks, by the way, for this. No, I'm not going to keep it. It's yours. It's yours. I'll give it back. Just don't let me forget about it. So we have 23 plus 45, right? Yeah. How is it that we usually add by hand? What do we do? Yep. Columns was the key word I heard. Or, like we just went over yesterday, the ones place, right? This is the ones place right here. And the 2 and the 4 is the tenths place. You're pretty much adding the columns' place values. So here, if we actually look at the 3 and 5, what is 3 plus 5? Let's look at the 2 plus 4. What does that become? Boom, 68, right? So now let's jump into the decimal side of things. What if we're given something like 46.28 plus 52.325. I'm just making all this up as I go, right? When you're given something like this, 46.28 plus 52.325, what must you do first when you're about to add them? Well, you want to make it look like this. You want to actually set it up vertically, right? So you want to actually make it so your columns are all lining up with each other, right? So that's what we got to do with this. But where do you line stuff up? So, yes, exactly. You line it up via the decimal. And this rule applies to both the adding and subtracting decimals. So what you need to do is line this up all together. So here, it doesn't even matter which one you want to, start with. 46.28, that's a 6. You know what, that looks too ugly. 0.28. And over here I had the 52.325. I'm just going to put the point there. I'm going to put the rest. I'm going to line everything up. Right? Now, that's fine the way it is, but if you notice, it's a kind of little jagged. I kind of don't like that. So what did I tell you yesterday's that numbers have in front and behind? Zeros. It has an infinite amount of zeros both in front and behind. And in this case, I'm going to fill that little empty space so I can make it nice and lined up, right? It helps you. You technically don't need to do that, but it helps you because what do we do now? Simple. We just add the same way we did here by looking at those columns. What does the 0 plus 5 become? Or what's 0 plus 5? 5. What about the 8 plus 2? All right. If you guys don't know it, the 10, the 1 goes up to the next one and the 0 down below, right? What's 1 plus 2 plus 3? The reason why we lined up the decimals is so that we could bring the decimal straight down and continue on. What's 6 plus 2? 4 plus 5. The answer is 98.605, right? Pretty straightforward. So when you're adding or subtracting numbers or decimal numbers, the key is to line up the decimals. So let's very, very, very quickly go over an example with subtraction. Just because subtraction is, even though it's the same, a lot of people do have a little difficulty with it. This time I'm just going to line it up already ready for us. 82.52. Then we have 4.935. Subtraction. What do I want to do? Put zeros. Make it a habit. It's going to help you with later math stuff. Just add any necessary zeros. Now it's all nice, right? So now, let's start subtracting. What is 0 minus 5? No. So later on in math, it's going to be negative 5, right? But we're not messing with negatives just yet. That's going to be fun. I love teaching positives and negatives. In this specific case, you can't do that. My gosh. So when subtracting by hands, they created the famous borrowing from the number next to the number, right? In this case, we could, wow, all of them are going to need borrowing. Ugh. But whatever. Let's say you didn't realize that. Let's just say you do this step by step. What you want to end up doing is taking 1 from this next one. So that you're going to borrow this 1 and put it into your 0. So what you end up doing is you end up making this 2 into a 1, right? Because you're minusing 1 from the 2, and then you're throwing it to the next one and making it a 10. What's 10 minus 5? Yeah, that's doable. You can actually do 10 minus 5 because the top one is greater than the bottom one. But then you come here, and what do you end up realizing? What's 1 minus 3? It can't be done. So we borrow from the next one. We make that 5 into a 4, and then we throw that 1 that we borrowed onto our other number, making it an 11, right? Okay. So awesome. Do you see how I just moved everything? It's all digital now. All right, so what's 11 minus 3? All right, now you move on. Our 4 minus 9. Oh, another problem, right? I'm going to have to borrow it. So you take 1 out from that 2 and make that 4 into a 14. Now what's 14 minus 9? There's the decimal right there. Now what's 1 minus 4? Again, cannot be done, right? The top one is smaller than the bottom one, which means I have to borrow from this one. Making that 1 into an 11. What's 11 minus 4? Seven minus 0? Oh, look, there's my answer. 77.585. So literally the same thing as addition. You line up the decimals. The only difference is, watch out for the the borrowing. Because a lot of people right off the bat do exactly that. They say, what's 0 minus 5? And they say 5. No. 5 minus 0 is 5. 0 minus 5 could be done, but not yet. In this specific case, it cannot be done. You have to go and borrow, right? All right, adding and subtracting done. Hopefully you guys are taking notes. What's next? Multiplying and dividing. Now, multiplying and dividing by hand, whole numbers within itself, a lot of people, it's cloudy. They've already forgotten how to do it by hand, just because they haven't done it a while. Add to that decimals, it's a lot to take in. So try to listen up for this. Multiplying, when multiplying decimals, let's get some good examples. Let's say we have 2.6 times 4.5. 2.6 times 0.45. What must I do? Does anyone know? So I heard line up the decimals, the columns, making it vertical. Is that what you mean? Yeah. Okay. Cool. Yes and no. So, yes and no. What we do want to do is make it vertical. Why? Because vertically we get to see it all, work with our columns, and multiply, right? The thing is, adding and subtracting is the only rule in which you line up the decimals. When multiplying or dividing, you do not line up the decimals. What you end up doing is kind of forgetting about the decimals. For just a brief second, you just forget about it. And you treat it as if this was 2.6, you treat it as if it was 26. The 0.45, you ignore it, and you make it 45. Do you guys see that? So now all you're doing is multiplying two whole numbers. The decimals are going to come back, don't worry. But for right now, to get the answer, what we do is we forget for just a brief second our decimals, and we make it into a whole number. And now we multiply. This is a good little review for those of you that forgot how to multiply by hand. How do we multiply whole numbers? Well, we start with this bottom one and we multiply it to the top ones. What's 5 times 6? The 3 goes up there, the 0 down below. What's 5 times 2? Plus this 3 that we added up top. 13, right? That's the first part done. What I then do is go on to my 4. The second digit of the bottom number, right? But whenever you move on to the next digit, what you got to always do is add a 0. Does that all ring a bell? Always add a 0 if you move on to the next digit, if you're moving on to the next one. So now you do the same thing. Just always keep in mind whatever it is that we did before, whatever we carried over, like this 3, just make sure to erase it when you start on with your new digit. So now what's 4 times 6? 2 goes there, right? 4 goes there, right? So now what's 4 times 2? Plus 2. 10. Now what you always got to do is add those. What's 130 plus 1040? Well, you guys already know how to add. What's 0 plus 0? 3 plus 4? 1 plus 0? 1 plus 0? All right. So 26 times 45, yes, it is 1,170, right? But that was in our original answer, or our original problem. Our original problem was this right here, 2.6 times 0.45, right? So now, where should my decimal go? We had erased the decimals for just a brief second and made it into a 26 times 45, but in math, things just don't vanish, right? We might ignore it for a brief second, but it must come back. What happens is, once you find your final answer, what you need to do is you need to go to your original problem, this one right there, and then you ask yourself, how many steps does it take to get to the center of a Tootsie Pop? No, that's a joke. How many steps does it take to move the decimal, this decimal right there, to the end? Yeah. Look at that. Decimal, boom. 1 step, right? That was 1 step we said? 1 step. Okay, let's move on to this decimal right there. How many steps does it take to get to the end? 1, 2. What's 1 plus 2? Guess what? My decimal is going to go in 3 places, 3 steps. So you start here at the end, right? And you move it 1, 2, 3. That's the location. Right there. That's an ugly one. .170 is your answer. So 2.6 times 0.45 is 1.170. Who is that? Who here is that new to? So like I said, for those of you taking your GED, well, I don't know if I said it or not. Who here is taking their GEDs, by the way? 1, 2, 3, 4, 5. So I got 5. Okay. For those of you taking your GED, the first 5 questions of the GED, you are not allowed to use a calculator. All right? Why? Because they're going to give you basic stuff like that. Stuff that they know that you could type into a calculator easily. But they want to see whether you've developed the skills to answer these questions with no calculator. So the first 5 questions are going to be simple stuff. Place value, roundings, fractions, percents, decimals. So be prepared for that, for those of you taking your GED. And for the rest of you that aren't taking your GED, guess what? You need to know how to do stuff by hand anyways. So we're all benefiting here. So that's how you multiply decimals. So recap of everything so far, adding and subtracting decimals, line up the decimals vertically, and just add or subtract the way you would whole numbers, right? The multiplying rule, ignore the decimal for just a brief second in time, and then make it whole numbers, and then multiply it out the way you would whole numbers. And then at the end, count your steps, and then put the decimal to whatever it is your step count is. What are we doing now? Who here is scared of division? Nobody? Nobody's scared of division? I was terrified of division when I was starting out because it's just too weird. To me, this is the weird operation of it all. So, who here remembers how to divide by hand? It's a lot of pattern-driven stuff, right? And in decimals, same thing. It's just a pattern that you got to follow. So let's look at something like this. 14.4, and they want you to divide it by 6. Well, that looks like a 2. It's supposed to be a dot. That's a division sign. 14.4 divided by 6. For those of you that don't know, how does this? What are you supposed to do first? Simple, put this into a division problem. So the first one always goes on the inside, 14.4, and then the second one always goes on the outside. This is how 14.4 divided by 6 looks like, right? So now, how do you divide? How do you divide? Quite simple, really. This is another one of those situations in which you sort of don't really, the decimal doesn't really affect anything here. If this is where the decimal is, and this outside number does not have a decimal, it's a whole number, right? All we know is that our answer will have a decimal right there. But pretty much you want to treat it as if it's 144 divided by 6. So it's another one of those that the decimal isn't too complicated here. So now we use our division techniques. For those of you that don't know, let's do it step by step. You want to always start little by little. What is 6? How many times does 6 go into 1? 0. It can't go into 1, right? 1 is smaller than 6. So we do that. It helps you. Trust me, if you guys keep organized, right? It's all a matter of keeping stuff organized. So because it can't go into 1, we combine those. Then you ask yourself, how many times does 6 go into 14? How many times did it fit in? Like, it fit in 2 times. How much was that times? Little quick note for you guys. In case you don't know what to put there, it's always this number times that number. What's 6 times 2? 12. And then what we do is we subtract. What's 14 minus 12? Bring down the next number. Don't worry about that decimal. We already put it up there, right? How many times does 6 go into 24? How many times, or what did it land on the 4 times? That's what we're always looking for, is the final 0. 14.4 divided by 6 is 2.4. Right? Pretty straightforward. The reason why this one was so straightforward is simple. Because the outside number was a whole number, right? If the outside is a whole number, it doesn't matter what's inside, whether it's decimals or another whole number, whatever. You just flop the decimal at the top. That's where the decimal will, the final answer, that's where the decimal will be. But let's look at something else. What if they end up giving you something like 4.9 divided by 0.35. So tell me, what should go inside the little division bracket? What should go inside? You guys got it wrong. It's not the 0.35, it's the 4.9. Remember, it's always this divided by that, which means the first one always goes inside. So 4.9 goes in there, and then the outside is the 0.35, right? So this is the second type of decimal divisions here. In case you ever see the outside number with the decimal, you must do something, all right? What we want to do is make that into a whole number. Pretty much make it not with decimal. not with a decimal. So how do I make this 0.35 into a whole number? You move the decimal. You move the decimal 2 places, right? That's how you get this decimal to the end. So if you move that there, it ends up becoming, hold on a sec. Hold on a sec. Ends up becoming a 35, right? But the thing is, if you move that on the outside 2 places, whatever is on the inside must now be moved 2 places. Whatever you do on the outside, you got to do on the inside. So, guess what? I have to move this decimal right there 2 places. Are you guys following me right now? We all good? If that's where the new decimal will be, that's where it'll be for my answer. And what should go here in this empty space? Those zeros. I told you guys yesterday that it was going to come in handy, those zeros, right? So now guess what? It's technically 490. And my answer, its decimal, if it does come out with a decimal, will be right there. Right there. So now let's divide 490 divided by 35. You see, we're learning decimal division along with traditional long division of whole numbers, right? So 490 divided by 35. Well, let's do it. How many times does 35 fit into 49? 1. It went in 35, only at 35, right? What's 49 minus 35? What now? All right. You do your traditional division step, bring down the next number, which is the 0. You bring it down and ask yourself the same question. How many times does 35 go into 140? What is it? What does it end up being? 140 exactly, right? And for those of you that are thinking right now, oh man, I gotta do 30. How many times does 35 go into 140? Like, I'm just gonna take out my calculator and do it. No. The whole point of this is to do stuff by hand, right? So you could guess and say, I think it goes in 4 times. All you got to do on the side of your paper is multiply 35 times 4. The same way we just did multiplying by hands, right? Your notebook, your scratch paper should have a whole bunch of little things on the side. Don't whip out that calculator just yet. We're going to learn the calculator and we're going to use it a lot later on. But right now we're trying to develop our skills of doing stuff by hand. Okay? So it went in 140 times because 35 times 4 is 140. And obviously when you subtract that, you get 0, which is what we're always looking for, is our final 0. And guess what? My answer is 14. 14.000, right? It doesn't matter. Infinite amount of zeros. This decimal was irrelevant. The answer is 14. So 2 types of division. We had a whole number on the outside, and again, it doesn't matter what's on the inside. You just treat it as a standard division problem. It's 144 divided by 6. And then the other type of division problem, when I erased it, but it was technically a 0.35 on the outside with again, doesn't matter what's on the inside. If the outside has a decimal in it, you must move it whatever amount steps it needs to be moved so that you make it a whole number. And just make sure that whatever is on the inside, you move it as well. That, my friends, is adding, subtracting, multiplying, and dividing decimals. Was it too much? Very straightforward? Any questions? No? Okay, cool. So, what I'm going to do now is give you guys your practice problems for the day, and you guys are going to work on it. And yeah, try to get it done today. If you can't get it done today, again, bring it in tomorrow at the start of class. And yeah.